Hello and welcome to Polynomials 3.3 Synthetic Division. Alright, today we are going to learn an alternative to polynomial long division. So it's a shortcut and it has its limitations, but if the right scenario is available or upon us rather, then using synthetic division is a very viable option and it's going to save you a lot of time, and you're going to think like, whoa, this is like a little bit too fast or too easy, so this must be wrong. But no, it's designed that way. So just make sure you learn it well, and you can use it whenever, like I said, the right situation arises. Okay, and just like in polynomial long division, it's going to work off a pattern where you're going to be doing the same thing over and over and over for a couple of rounds. And once you get that couple of steps mastered, then, like I said, it'll be pretty easy and you'll kind of enjoy doing it. All right, so let's move on to the next slide. So this next slide is going to tell you the process of what you're going to be doing. It looks pretty complicated when you just look at the amount of words you see on this slide, so don't worry about it. I will explain everything through doing problems live. Okay, so let's just go to our first problem. And I kind of like the second problem as our lead-off problem, because the first problem kind of has some special things that you got to take into account. So I'd rather show the second problem first. Okay, so first thing we want to do is we want to set up the problem, and we're going to create kind of like the format for how it's going to fit and how I'm going to plug everything else in. Okay, so I'm going to draw my backwards L first, and there's going to have a number inside that backwards L. Okay, and the number that's going to go in the backwards L is basically going to come from the second parentheses, so the x plus 3 basically. Okay, and we've been doing the step that we're about to do a lot recently, and we've been doing it a lot basically when we do x-intercepts, right? So if I were to ask you a question and I would say x plus 3, what would be the x-intercept that corresponds to the parentheses x plus 3? You would say, oh, negative 3 comma 0, and that'd be correct. Okay, so the number that we're going to put in the backwards L is going to be the exact same number that we would use for x-intercepts. Okay, so since x plus 3 would be negative 3 comma 0, the number we're going to put in the backwards L is negative 3. Okay, and then we're going to put numbers on the right side of this backwards L, and it's going to basically be the coefficients of all my terms. So I'm not going to write any of the x to the fourth, x to the third, x squared, x. I'm not going to write any of those letters. All I'm going to do is write the numbers that are in front of the letters. Okay, so let's start off with 2, because that's my first number. Then it's followed by a 6, then a 1, then a 7, and a 12. Okay, so all I did was I wrote the coefficients for all my terms, and I purposely left out the letters. All right, then next I'm going to draw a line underneath everything that I just wrote, but I want to leave a space because there's going to be numbers that I'm going to write underneath each of these numbers. So I want to leave a little space because I'm going to put stuff there in the middle. All right, so let's officially start this process called synthetic division. Okay, so step 1 of synthetic division requires you to combine top and bottom. And you're going to say top and bottom. What do you mean top and bottom? I see a top, I don't see a bottom. Okay, so don't get thrown off by what top and bottom means. It's just going to mean basically you get the number on the top, which in this case is a 2, and you combine it with the number on the bottom, or the number right beneath it, which is nothing. So therefore 2 plus nothing is 2. Okay, so that's step 1 of round 1. Okay, step 2 of round 1 is going to be the number that we just put on the bottom, 2, is going to multiply to your number in the backwards L. So 2 times negative 3, and that's going to make negative 6. Okay, so round 1 is officially done. Okay, first step was add top and bottom. Second step in round 1 was the number that's on the bottom now, the one that we just combined rather, is going to multiply to your backwards L number. Yeah, and that completes the round. And all we're going to do is just pretty much repeat this exact same process. So add the top and the bottom numbers, so 6 and negative 6, that makes 0. Then multiply that number to your backwards L, which is negative 3, and that's going to make a 0. So round 2 is now done. Okay, now let's do round 3. Okay, so add top and bottom, we get a 1. multiply to your backwards L number. So 1 times negative 3 is negative 3. Okay, round 3 is now done. Now let's start round 4. Okay, so add your top and bottom number, that makes 4. Then multiply to your backwards L. 4 times negative 3 is negative 12. And round 4 is done. Okay, so we're gonna do one more round, but it's not really a complete round because we're not gonna have anything else to combine it with after the 12 because 12 was our last number. So when you're on your very, very last number, here's what you're gonna know about synthetic division and if it's working correctly. Okay, we're gonna get a 0 for this last column, always. Okay, and it's not always gonna be like that, so I shouldn't really say that, but because we made sure that we put problems that were gonna work. Yeah, you're gonna get a 0 for all your problems on classwork on this video and all your problems for homework. And if you don't get a 0 for this last column, then you know you did something wrong. Because like I said, we purposely plan so that all the problems come out nicely. And you're gonna get a 0 for this last column. And if, like I said, if you don't get a 0, then you messed up. You either added wrong or you multiplied wrong or you forgot something. Yeah, but you messed up somewhere and that's why it's not coming out to a 0. Okay, so those are the 4 rounds of synthetic division. You saw me do the exact same thing 4 times. And now that we have the process called synthetic division finished, we have to put back what we took away in the very, very first step when we started to prep the problem. And when we prepped the problem, we took away all the x's. Okay, so because we're now at the end of the problem, we're going to have to put the x's back. And we can't just put back any old x we want. There's a certain pattern we have to follow as well. Okay, so notice how I put that last number in a box. Yeah, and I don't know if the packet says to do that. I mean, I'm pretty sure it doesn't, but I do it anyway. Because when I start to put back x's, what I tend to notice is when I don't have this box there, I make a mistake. Yeah, and I put an x where it shouldn't be. So there's a box around that last number. So when I start giving back the x's, I'm gonna give back x's to all the numbers that are outside the box. So I give an x to him. Hey, how come it's not writing? Okay, I give an x to this guy 4. I give an x to the 1, I give an x to the 0, and I give an x to the 2. So everybody gets x's except for the number in the box, the 0 that's in the box. We don't give him anything. Okay, so next thing I'm going to do is I'm going to give everybody a power. And when you give back powers, always start from 0 on the far right hand side x. So this guy gets a 0, a power of 0. This guy gets power of 1, then power of 2, then power of 3. So you're just going to go in order. Okay, and we're almost done actually. So here's your final answer. So your final answer, let's change it back to blue, is 2x cubed. And we don't really have to write 0x squared because 0 and x squared just pretty much cancels out. So we can just leave that alone. We can just ignore it. And then the 1x to the first power. You can write 1x to the first power if you want, or you can just write positive x. Yeah. And then we're going to follow it up with plus 4. And you're going to say, oh, where's the x to the 0 power? Well, if you understand what a power means, the power tells you how many of that letter we have. So if we have a power of 0, that means you don't have the letter x. And that's why all we see is a 4. Okay? And this problem is done. Yeah, so you see how this works? So like I said, when you do synthetic division, it's all about following that pattern. Okay? And you're just going to repeat that pattern as many times as you need until you get that 0 in the last column. Okay? So let's go to number 1. And let's do this same exact type of problem right now. All right, so we're going to set it up. We're going to make our backwards L. And we're going to put a 5 in the backwards L. Because that's the number that would cancel out x minus 5. Right? Okay, and then we're going to put the coefficients next to this backwards L. So we're going to start with a 4. And we have a negative 500 all the way at the end. And you're probably thinking, whoa, what are you doing? Why did you leave all that space in between 4 and negative 500? Okay, well, there's a little rule that is kind of just like when we did polynomial long division, that if you're missing any powers, any terms, you must hold its place with a 0. Okay, so we went from 4x to the third power all the way till 4x to the 0 power. So we cut out a lot of x's, right? There's a lot of x's missing. So because we have a lot of x's missing, or a lot of terms missing in between 4x cubed and negative 500, we got to fill that spot with a 0. Okay, and if we don't do that, then our answer is going to guarantee be wrong. So please, please, please make sure if you're missing any powers, you fill it in with a 0. Okay, so you can kind of think of it as like a placeholder. All right, so we're missing the x squared term, so we're going to put a 0 for x squared. We're missing x to the first power, so we're going to put a 0 for x to the first power as well, so it can hold its place. And then x to the 0 power, that's represented, that's negative 500. Okay, then I'm going to draw my line, and be sure to leave a space. Oops, how come it's not drawing a line? Be sure to leave a space between the numbers that I just wrote and the line that I just drew, so leave a space there. Okay, and if you're really thinking ahead, you can actually go and pre-plan this box right here and put a 0 in there, because like I said, every single problem, whether it's on classwork on the video or whether it's for homework, yeah, we were nice. We planned it out so that every single one of these problems is going to get a 0 at the end. Okay, it doesn't always work like this when you do synthetic division for real, but like I said, since we just taught this to you just now, we want it to be nice, yeah, so that everything comes out to nice answers. All right, so let's start round one. So add the number on the top and the bottom. So 4 plus the number beneath is 4. Yeah, because there's nothing underneath the 4, so they're basically 4 plus nothing is 4. Okay, then we times it backwards out, so that makes 20. Okay, round one is done. Let's start round two. Add top and bottom, we get 20. Multiply to your backwards L, we get 100. Round two is done. Okay, start round three. Add top and bottom, we get 100. Multiply to your backwards L, we get 500. Round three is done. Can you see how fast these rounds are? So if you know how to add and multiply really quickly in your head and you don't need your calculator, then you're gonna fly right through this thing called synthetic division. Yeah. Okay, so let's see. Did we get our 0 at the very, very last column? Is negative 500 and positive 500 going to cancel out to make 0? Yeah, I think so. It's going to cancel out. Okay, so synthetic division, the process is done. So let's put back our x's, the same x's that we took away in our very first step. So first you want to give everybody an x, and then you want to give everybody a power. So start with 0, and then just work your way up. So 0, 1, 2. And then you're going to write our answer on this blank line, so 4x squared. And then plus 20x. You don't really have to write the power of 1. You can if you want to, but you don't have to. And then plus 100. And you're done. Okay. All right, let's look at problem number 3. Okay, so this is where we're going to finally throw our curveball. And you're not going to like what we do, but yeah, sorry. Can I help? Okay, so when you look inside the parentheses, you see a very weird set of numbers inside the parentheses. Okay, so there's one thing that synthetic division has that is kind of like it's being picky. And if you don't satisfy that need, yeah, for him to be picky or the process to be picky, then it's not going to work. Okay, and the thing about synthetic division is this. Okay, if you want to ever use him, you cannot have any kind of a number other than 1 in front of the x inside your parentheses. Okay, that's a rule. Yeah, so if there's a number in front of the x that is not 1, then you can't use synthetic division until you fix that problem. Yeah, and the problem, like I said, is there's a 2 in front of the x, and he don't like that. Yeah, he only wants to have a 1 in front of the x if you want to do that process called synthetic division. Okay, so to fix this, you're going to have to do division. You're going to have to divide that 2x by whatever number it's going to take to turn it into a 1. Okay, so what is going to be necessary to turn a 2 into a 1? Yeah, what are we going to divide by so a 2 turns into a 1? And hopefully you're saying, I think a 2 divided by 2 is going to make it into a 1. And if you did say that, then you're perfectly correct. So we're going to divide everybody by 2. And you got to remember this part. This part is super important. You got to divide everybody by 2. You can't just divide the 2x by 2. You got to divide everybody by 2. So we got a brand new problem, and that brand new problem looks like this. So x to the third plus 15 over 2 x squared minus 2 divided by x minus 1/2. So that's our brand new problem. Okay, so once we have our brand new problem and we have our parentheses with the regular plain old x, yeah, minus 1/2, it's going to be hopefully pretty easy to figure out what number is going to go in the backwards out, and that's going to be a half. And then we're going to write the coefficients next to the backwards out, so it's going to be a 1, a 15 over 2, and you're going to say, oh no, fractions. Yeah, I know, sorry, fractions, kind of ugly. And then be careful now, we're missing x to the first power, so we got to fill it in with a 0, and then a negative 2 at the end. Okay, so we're going to draw our line, leave a space for numbers to be written underneath there, and put a little box. And since I said every one of these problems has been planned out so that it's going to become a 0 at the end, you can just go and automatically write the 0. Okay, if this is not something that we're being nice about, then yeah, it's not going to be 0 all the time. But like I said, for this section, we're being nice. But in the future, it's not going to always be 0. Okay. All right, so let's start. Add top and bottom, we get 1. And multiply to your backwards L, we get 1/2. Okay, so add top and bottom, so 15 over 2 plus 1 over 2 is otherwise known as 16 over 2, which is also known as 8. Okay, so multiply to your backwards L, 8 times 1/2 is 4. Okay, add top and bottom, we get 4. Multiply to your backwards L, we get 2. So notice how we just went through our rounds. This is basically 3 rounds of doing the exact same thing. Add top and bottom, multiply to your backwards L. Add top and bottom, multiply to your backwards L. Add top and bottom, multiply to your backwards L. So you see how it's the same thing happening, just those 2 steps happening as many times as you need. Okay, and did we actually get our 0 at the end? Yeah, we did. So we know we did it correctly. Okay, so the rounds are done. Let's put back the x's. So everybody gets an x. Yeah, everybody gets an x, and then we're going to give power. So start always with power of 0, then work your way up. So 0, 1, then 2. Okay, so let's write our answer on this blank line. So we have x squared plus 8x, and then plus 4. And that's all done. Okay, last problem. Okay, you're like, oh my goodness, look at how ugly this problem is. That's probably what you're thinking. Okay, so right now, like I said, synthetic division, he's very picky. He doesn't like that 4 that's in front of the x, so we're just going to get rid of it. Yeah, and the way to get rid of it is divide by 4. Okay, but you can't just divide the 4x by 4. You got to divide everybody by 4. Okay, that's a rule. You cannot go around that rule. It has to be done. And you're probably thinking, whoa, 4 does not divide into everybody nicely. So we're going to get some ugly numbers. And yeah, we are. So sorry about that. Okay, so let's see what we have left. So we have 2x to the 4th minus, and then we can simplify this fraction, right? 10 over 4 simplifies to 5 over 2. X to the 3rd power. Okay, you don't have to simplify if you don't want to. I mean, smaller numbers will make your calculations easier, but if you leave it as the big numbers, then it's still going to work out. But like I said, you're just going to have bigger numbers that you have to deal with. So it's always better off trying to simplify if you can. 25 over 4 doesn't simplify, so just leave it as that. 36 over 4 is known as 9x. And 45 over 4, that doesn't simplify, it just stays 45 over 4. So yeah, these are some ugly numbers, sorry about that. And divided by x plus 5 over 4. Okay, alright, wow, am I going to have enough space to fit this synthetic division? I think this is a big problem. I think I wrote too big. Well, let's see, let's just make the best of it. Okay, so what's going to go in the backwards L? Actually, I don't want the backwards L to be over there because now it's kind of too close to the problem. So let me squish it over a little bit more. Okay, so negative 5 over 4 is going to be in the backwards L. And we're going to write the coefficients. Is anybody missing? X to the 4th is here. The 3rd, 2nd, 1st, 0. Okay, nobody's missing, so we've got to put zeros, thank goodness. Okay, so we got 2. Oops, how come it's not writing 2? Negative 5 over 2. Negative 25 over 4. 9. And 45 over 4. So I kind of had to squish. I don't really like squishing like this, but I cannot help. I guess I didn't really pre-plan everything out, so that's my fault. Okay, and we're going to put a 0 in there because that's the number I'm expecting. Okay, so let's add top and bottom. So that's going to be a 2. Okay, and then we're going to multiply to our backwards L. So 2 times negative 5 over 4. So guarantee that's a negative, right? Because positive times a negative is a negative. Okay, and then 5 over 4 times 2. Yeah. Okay, so this is the part that you might want to have to work some stuff out on the side. So 5 over 4 times 2 over 1, right? So when you multiply, you got to make everybody into a fraction. So you can go top times top, bottom times bottom. So top times top is 10, bottom times bottom is 4, so that's 10 over 4, which is also known as 5 over 2. Okay, so we got negative 5 over 2 on the top, and negative 5 over 2 in the bottom. Okay, so negative 5 over 2 plus negative 5 over 2 is negative 10 over 2, which is known as negative 5. Yeah. Okay, so now we're going to go and multiply to our backwards L. So negative negative makes a positive. And 5 over 4 times 5. So let's multiply that out on the side here again. Let's make a little separation. So 5 over 4. And notice how I'm not writing negative 5 over 4 because I already know my answer is going to be positive. Okay, and then times 5 over 1. So that makes 25 over 4. So I can put a 25 over 4 there. Okay, I'm really squeezing this in. Okay, so negative 25 over 4 plus 25 over 4 is 0. Oh, good. Thank goodness we get nice numbers. Okay, and then 0 times negative 5 over 4 is 0. All right. Add top and bottom, we get 9. And in our last multiplication, we're going to have a negative answer because this is a positive 9. Sorry, let me get rid of that little mark. That looks like it's going to be a negative, so let me get rid of that mark. Okay, so it's positive 9 times negative 5 over 4, so that's a negative answer. So we got 5 over 4 times 9 over 1, and that makes 45 over 4. So I put a 45 over 4 right underneath that one. And ooh, I kind of made that line a little too big, so you can't tell that it's a negative anymore. So let me just erase some of it and put back my negative. So we got positive 45 over 4 minus and negative 45 over 4. So that's going to cancel out. So there's my 0. So I get what I want. Okay. So yeah, this problem, notice how the steps were the same. Yeah, that's what you got to understand. The steps were the same. It's just that my numbers were ugly. Okay. All right, so let's put back our x's. So everybody gets an x. And then everybody's going to get a power. So start with 0 and work your way up. So 0, 1, 2, and 3. Okay, so let's write my answer on this line. And let me change the color. Let me just write everything in red because there's a lot of blue all around the place. So my final answer is going to be 2x to the third power minus 5x squared. And then the 0x to the first power, we don't got to write that because 0 is just going to cancel it out anyway. And then we got positive 9. And we don't got to write x to the 0 power because x to the 0 power means there's no x's. So that's why we just put positive 9. And yeah, actually that's our final answer. Okay, so that was the final problem. I hope everything made sense. Everything I should have made sense. I mean, it's not like the process changed, right? It was basically add the top and the bottom, multiply to your backwards L. Yeah, it's just that we ended on a very sour note because the numbers in the last problem were not very nice. But if you really think about it, we're still doing the exact same process that we did in the previous 3 problems. Okay, so just watch this video as many times as you need so that you can understand what's going on, and the homework is going to be pretty much just like it. All right, so good luck on this, and I will see you in class. Bye-bye.